4.1, we're going to just kind of learn the basics today of equivalent equations. So basically an equivalent equation is when one thing equals another thing. Like you could say that x equals x, because you know that those are both of the same thing. We could also say, if we know what x represents, let's say that this box here, there are 3 parts. 1, 2, 3. And this whole thing is x. We could say that x equals 3, because 3 is the same as saying x. They're equal. So we can draw this in a balance, because let's say on one side of the balance, we have that whole bar of x, the whole thing here. The other side, we have 3. 1, 2, 3. Well, they're equal because x is equal to 3. So the balance stays. And so we would represent that with our equation as x equals 3. Now, we can do a little bit more details. We could make something bigger. So, for example, we could say that here's our balance, and on one side we have x, but we've taken away 1. So that 1 is no longer there. The rest is our x. So here we have x minus 1. Alright? Now the other side, we have 7 little blocks. Okay, if we were to squeeze these all together, they would be equal to this. See, our balance stays the same. So those 7 little blocks are equal to x minus 1. Now, let's say that we wanted to figure out, okay, what actually is x? Well, if we added 1 to this side, because we have one little box, well, the balance would start going this way, and we don't want that. So we would have to add 1 also to this side. So then that gives us x minus 1 plus 1 on this side is equal to 7 plus 1 on this side. So overall, a minus 1 and a 1 is just equal to x, because you add that in, the whole box is filled up. So then the other side becomes 8. So we know that x itself equals 8. The equation is now balanced. Okay, let's try something else that we can do to both sides. So we've added 1 to both sides. Let's say we have the same thing, but this time rather than adding, we decide that we want to subtract. Okay? So let's take from here 2 boxes away. Alright, so we have 2 boxes. We are going to lift them away. Well, if we lift them away, this becomes lighter, so then the balance kind of goes that way. We want it to stay because it's an equation. This is like our equal sign. Okay? So we also have to lift away 2 from here. And that becomes these 2. They're gone. These 2, they're gone. So our equation looks somewhat like this. We start with x minus 1 equals 7. Then it becomes x minus 1 minus 2 equals 7 minus 2. So now x minus 1 minus 2 is x minus 3. And over here, you get 5 left. 1, 2, 3, 4, 5. So x minus 3 equals 5. Okay? We could change it again. Okay, we could go back to when we solved our equation, because we could add 3 back to both sides. So now if we carry this down, kind of like here, I'll show you the picture. They simply add it back in. You can add 3 and it becomes x equals 8. Now we've done adding, subtracting. Let's try multiplying. Okay, so let's start out. Here's our balance. That's like our equal sign. We start out with, let's start out here with x, just x, and then on this side we start out with 8 because we found out already from up here that x is equal to 8. Woo. Let's fix that. The light's coming in really strong. Let me go close the shade. Okay. Whoops. Alright, now let's try it. So multiplying. Well, if this side is x and this side is 8, and we want both sides to stay equal, but multiply, let's say we want to find out, well, what would happen if we had another x? Okay? So we have now taken this one and we've multiplied it by 2. So now we now have an x and an x. We multiply by 2. So if we multiply this one by 2, we no longer just have one group of 8s, we have another group of 8s. Okay, so we have 2 groups of 8s, we have 2 x's. So our equation, x equals 8, becomes 2 times x equals 2 times 8, and we know that that is 2x equals 16. So 2 x's together equals 16. Now, we could do something else. We could divide everything. So let's say that here's our balance, here's our equal sign, and let's start out with our x again. Let's start out with our 8 again. Let's say I want to figure out what is half of this x. So I divide it in half, divide it by 2. Well, if I got rid of half of this, the balance would go that way. We don't want that. We want it to go to the center. So to get rid of part of this one, we also have to divide by 2. So a way that we can write that, x equals 8, is we could either say x divided by 2 equals 8 divided by 2, or we could say x times 1/2 equals 8 times 1/2, because multiplying by 1/2 is the same as dividing by 2. Or we could say x divided by 2 equals 8 divided by 2 as a fraction. So there's 3 ways to write it. 1, 2, 3. But either way, any way we write it, it gives us the equation of 1/2 x equals 4. So a half of this x equals 4. And we can do that in dividing. Alright, let's try an example. So A, state whether each pair of equations are equivalent equations, give a reason for your answer. Okay, so we have x plus 3 plus 6x equals 13, and 7x plus 3 equals 13. Alright, are these two equivalent? Well, let's use the property of rearranging to figure this out. So x plus 6x, I'm just going to move this right here, plus 3 equals 13. Alright, now we have 1x and 6x's, so those can combine to make 7x plus 3 equals 13. Same? Yes. Alright, they are equivalent. B, 5x plus 4 equals 6, and 5x equals 20. Alright, we just used the property of rearranging, but now we're going to use the property of subtracting, or of, sorry, that's a minus sign. We're going to use the property of adding. So here we just have 5x. So if we want to get just 5x here, we could get rid of this 4x by adding 4 to this side. Now remember, it's a balance. If I add to this side, it's going to tip. We want it to be equal, so I need to add 4 to both sides. Now I draw a line, okay, and then I'm going to add it kind of this way. So I carry this 5x down. Minus 4 and a plus 4 becomes nothing. I carry the equal sign down. 6 plus 4 becomes 10, and then my equation is 5x equals 10. Same? No, not the same, so they're not equivalent. Let's try another one. See? 2/3 x equals 4, and x equals 6. Alright, so we want to get rid of this 2/3. So a way we can do that, because we only want x, is we could say 2/3 x times 3/2, because we multiply times the opposite fraction, the 3 and the 3 will cancel, the 2 and the 2 will cancel. Now if I only do that to one side, it becomes a balanced. So I need to do it to the other side. I multiplied by 3/2. This side needs to be multiplied by 3/2. Okay? So x becomes 4 over 1 times 3/2. Can we reduce this? Yes. That becomes 2. That becomes 1. And we have on the top 2 times 3, which is 6 over 1. And then on the bottom, it's just 1. So we could say that x is equal to 6. Same? Yes, they are equivalent. Okay, I want you to try this in guided practice. 1, 2, 3, and 4. That's all for today.